In your last video you watched, in your last set, we learned about row reduced echelon form and how row reduced echelon form, just pop it up here real quick, has ones diagonally and then zeros everywhere else. So this is a 2 by 3 matrix, or in a 3 by 4 matrix, still same idea, ones diagonally and zeros everywhere else. Don't forget, we still have our equal sign, so that far column on the right wouldn't, of course, have ones or zeros, unless that was part of your solution. So our general strategy for solving a system of equations with a matrix, again, is to get our matrix into row reduced echelon form. And that row reduced echelon form is abbreviated RREF. And we'll see that abbreviation on our calculator in a little bit. If we can get our matrix to row reduced echelon form, that'll tell us our solution. So how are we going to do that? Well, we can do a lot of the same things that we can do to systems of equations with elimination that we can do with matrices. So if you think of some of those things that we can do, we can multiply an equation by a constant. Same way we can multiply a row by a constant. So for example, if we multiplied a row by a constant, if we had the matrix 3, 2, 5, 2, negative 1, 3, this matrix could become 6, 4, 10, 2, negative 1, 3. So we just multiplied our top row, everything in our top row by 2, same way that we would multiply both sides of an equation when we're solving with the elimination. We can do that. All right, so that's one thing that we can do. Another thing we can do, we could just switch rows around. So think about when we had our equations with x and y. It doesn't matter which equation we had on top. We can interchange those equations. Same thing with matrices. So this matrix could become 2, negative 1, 3, 3, 2, 5. And then the last operation that we can do with matrices is to add one row to the other. And this one's kind of weird because let's say I have my matrix stick with that original 3, 2, 5, 2, negative 1, 3. If I add my rows together, what happens? 3 plus 2 is 5. 2 plus negative 1 is 1. 5 plus 3 is 8. That top row changes, the bottom row stays the same. All right, so this add one row to another with matrix operations is different from what we're used to with our system of equations. But this is just kind of one of our rules with matrices. That's how we add our rows together with a matrix. All right, so we will use this strategy in our next example to solve a system using matrices.